Okay, so hopefully this will be the first of many easy to read, clear, easy to hear videos that work for our class. So hopefully this works. So our topic for today are simple machines. And a simple machine is a device that helps make work easier by changing the size or direction of a force. So basically it's a very basic item that we're going to use to do tasks to make it easier. It's either going to change the direction so it's easier on our bodies, or it's going to reduce the amount of force that we need to do to get something done. So that's good. It makes it easier for us. There are several different types of simple machines that you might have learned about in primary school, but we're only going to cover two main types in 6th grade, and you'll learn more about others next year. So the first type is an inclined plane. An inclined plane is a simple machine that is a straight, slanted surface. And so when you hear inclined plane, think of a ramp. Okay, so anytime you see a ramp going into a building, or maybe like off a curb or something, that is an inclined plane. And they look like this. They have one flat side on the bottom, a flat side on the side, and then a slanted side on the top. Okay? When you have an inclined plane, the longer it is, the better. So for example, I drew two inclined planes here. Both of them are going a total of 2 meters high. But this one reaches at 2 meters, and it only takes 2 meters to get there. Where this one, it's also going 2 meters high, but it takes 4 meters to get there. So it's not as steep. Like, it's a much more gradual, gentle slope than this shorter one. So if you're going the same height on an inclined plane, you always want your ramp or your inclined plane to be longer because it makes it easier on you to go up a bit. So that's an inclined plane. So inclined plane is pretty basic. There are two specific types of inclined planes we're also going to talk about. The first of which is a wedge. And a wedge is a simple machine that is a doubled inclined plane that moves, and it's often used for cutting. So I drew an example here. So if you look at this, this is a wedge, and if you see, we have our flat sides. We have a flat side there, and then a slant at the top. And then we also have an inclined plane flipped upside down to where there's an inclined plane here on the bottom also, with the flat side, and then the slanted side. So this takes two inclined planes, it flips one over and puts them side by side. So it has this kind of triangle shape. Now this point here can be very sharp, and so that's why you find wedges in axes and knives. So if you take a butter knife at your house and you look at it, like you hold it this way towards your face, you will see the edge, the sharp edge of the butter knife, it's a wedge. So it has this kind of like gradual point on one side. So a butter knife at your house, don't do like a steak knife, don't stab yourself in the face. Do a butter knife. But you will see on the side that it has a wedge. So wedges are really sharp and they cut through stuff because they can cut through here and then spread stuff out. So wedges can cut. The other type of inclined plane is a screw. And a screw is a simple machine that consists of an inclined plane wrapped around a cylinder. So basically a cylinder, remember, is a round 3D shape, and it has an inclined plane wrapped around it. So I drew a screw here, Phillips head, and it has an inclined plane wrapped around it all the way down to the tip. So if you look at a screw and you look at these threads, the thing that's wrapped around it, if you look at them, they are slightly slanted. And so it's an inclined plane, a really long inclined plane that's wrapped around that cylinder all the way to the top. And where we see screws are screws, like when you're building furniture or putting something together. Bottle caps, so like at the top of a bottle, it has those threads around it. That's an inclined plane around the top of the bottle. And then if you look on the inside of the bottle cap, it has the threads also, and when you screw those together, they stay put. So a screw is a version, it's an inclined plane, it's just a different version of it. So same thing with wedge. So inclined plane, wedge, screw, these are all related. They're types of inclined planes, and they help us do stuff. Lift boxes or cut stuff or hold stuff together. So the other type of simple machine we're going to talk about this year are pulleys. And a pulley is a simple machine that consists of a grooved wheel that holds a rope or a cable. So it's a wheel, it's a circle, it's kind of like a donut, it has a hole in the middle, And on the top edge, it has this groove that a rope sits into. And I'll try to find one so we can look at it in class. So it has a cable that runs over the top of it, and then you pull on one side. And so an example of a pulley are window blinds. So when you pull on the string to make the blinds go up, that's a pulley. The pulley is at the top. And you're pulling down on the string to make the blinds go up. And garage door openers has the same thing. So the machine has a pulley in it, and it pulls the garage door up. So the more pulleys you use, the easier it is to lift your object. So if you have a really heavy object and you just have yourself to lift it, if you use multiple pulleys, then you can possibly lift it by yourself. But if you just use one pulley, it does not reduce the force. It only changes the direction that you pull. So if I have a box sitting on the floor and I don't have any pulleys, I just have to lift it myself, I have to lift it this way, right? Which could be awkward. It could hurt my back. It could hurt my arms or something. So if you're lifting a box, that's one direction, a direction. And if you attach a pulley and you're pulling down on a rope to lift that box, you're not lifting this way, you're pulling this way. So it could be more comfortable for you to pull. So if you're using one pulley, it changes the direction from a lift to a pull, but it does not reduce the force. If you use multiple pulleys, then we can reduce the force, and we'll see how to do that next. Okay, so to calculate the force needed to lift an object with pulleys, you divide the weight in newtons, we're going to weigh things in newtons for now, by the number of supporting ropes. So you divide the weight of your object by how many ropes are holding it up. You do not count the end of the rope you are pulling on. Okay, and I'll show you what I mean. So here, that is you, looks just like you, I know. That's you, and you're trying to lift up this box that weighs 100 newtons. But you're a smart cookie, and you knew from science class that that might be hard to lift, so I'm going to use some pulleys to make it easier. So we're going to count the number of supporting ropes. You do not count the end of the rope you are pulling on. So we are not going to count this first rope because that's the rope you're pulling on. So we have a rope here. That's 1, 2, 3, 4, and this rope that's attached to the box. So we have 1, 2, 3, 4, 5 ropes. You do not count this first one, okay, because that's just the one you're pulling on. So 1, 2, 3, 4, 5 ropes. So it says here, you divide the weight by the number of supporting ropes. So we're going to divide the 100 newtons by the 5 supporting ropes, 1, 2, 3, 4, 5, and we're going to get 20, and then our label is going to be newtons. So if you were to set up this system to lift a box that weighs 100 newtons, if you had 5 supporting ropes, you would only need to pull with a force of 20 newtons. So now, not only do you not have to lift the box, you can pull, which is probably an easier motion, but you don't have to lift 100 newtons worth of the box, you only have to pull with a force of 20 newtons. So this makes it a lot easier and lighter for us to lift things. So this makes it possible for us to lift very, very, very heavy things with a lot less force. So you divide the weight by the number of supporting ropes, and that's it.